Ladies and gents, my name is Brandon Stover. Welcome to the How to Solve Climate Change course from Plato University. Causes, systems, obstacles, solutions to this global challenge is what you're going to learn here today. When you're ready to learn more skills, join us for free at plato.university. Let's get started with today's lesson. We'll have our expert guests briefly introduce themselves and their credentials for why they are able to speak to this topic.
So my name is Joshua Rhodes. I'm a research scientist at the University of Texas at Austin and a non-resident fellow at Columbia University, where I study energy systems and how they interact with society at large. And in general, specifically about smart grids, it was the topic of my dissertation work. So I looked at how all of the highly granular data sources that were emanating off of, all these smart things and devices and other stuff on the system could be used to, reduce energy use and other types of things like that.
And could you explain to us what smart grids are from a first principles perspective?
To talk about smart grids, let's first talk about dumb grids, or no one really calls them dumb grids, but the traditional grids that we think of. So these can be things like the electricity sector, water sector, natural gas sector. These are basically conduits for moving either energy or some kind of energy carrier from where it's either being produced or stored to where it's being consumed. And so most people in this case, they think about electricity. And so electricity is produced at, power plant. Traditionally, it's produced at power plants. It goes on big transmission lines, and then it gets on the small lines that, maybe run it down to your home or apartment. What the smart grid does is it puts an information overlay on top of that, and it allows not only energy or commodities like water or gas or things like that to flow, but it also allows information about how that energy is being used and, maybe ways of, using that energy in a smarter way. So one of the smart grid kind of 1.0 was just to really see how energy was being used at the end use. Because traditionally with electricity, someone actually came around in a car or truck and physically looked at your electricity meter once a month, and they billed you for the total amount of electricity that you consumed. What the Smart Grid 1.0 allowed was it allowed these smart meters to basically take snapshots about every 15 minutes or so. So it is a much higher granular amount of information about how energy was being consumed. And then as we got into the Internet of Things and further iterations of the smart grid, it allowed not only information to flow, from where it's being consumed, but also to where it's being consumed in terms of, maybe setting up thermostats to, reduce energy use during certain parts of the day and things like that, or when times are more carbon intensive. Lots of programs that allow things like that to happen.
Why would these smart grids help to solve climate change?
In the electricity sector, so you can't manage what you don't measure type thing, that old adage in business. And so if you don't know when electricity is being consumed necessarily, you're not going to be able to make any kind of prediction or be smart about, changing that necessarily. And as electricity grids in particular have more things like wind and solar, lower carbon sources of energy on the system, that electricity is not being generally that lower carbon electricity is not being produced all the time. Solar is only being produced when the sun's shining, wind's only being produced when the wind's blowing. And so if you can send signals to appliances that maybe don't have to operate at a specific time, say if you wanted to run your washing machine or your dryer during the time when there's more wind or solar on the system, you can do that, and the dryer will turn on whenever, maybe the electricity is lower carbon. And so you can better align demands with production, and then that helps us, meet all the energy services we want, warm water, clean clothes, etc., using less carbon for the energy that it takes to actually get us there.
Looking at the flip side of it, why would it not help to solve climate change, or maybe where does it fall short?
So I guess where it could fall short is you can have all of these data, but if you don't know how to if you don't know how to take actionable steps with those data, then you can just have a bunch of data for data's sake. And so one has to going back to the old adage, you can't manage what you don't measure. Just because you measure doesn't mean you're going to manage. And so, if you don't have the systems that are able to be smart about that, or that are able to ingest these massive amounts of data and, do something useful with them, then you just deployed a bunch of, fancy electronics that might not do anything. which there were some iterations of Smart Grid 1.0 that kind of happened, like a lot of data just got produced and not much was done with it. But as other companies and systems have gotten into that game, they're trying to be more proactive. But you have to actually do something physically. The data have to make a physical change for there to be a change in carbon emissions, which leads to a change in or climate outcomes.
Thinking of all these stakeholders that are around these smart grids, who may benefit the most as this being a solution, and then who may be harmed most with it being a solution?
So those that stand to benefit the most from these data streams being able to take are those that are able to take the action associated with any recommendations or feedback from these data streams. So those generally, like the early adopters, the ones that were able to afford to buy the interruptible switches or the thermostats and things like that would respond, or lights that would turn off on their own, or other things like that. So those that were kind of able to afford those technology pieces, I think were some of the ones that were able to benefit the most. One of the early narratives about the smart grid was that just giving people information would change their behavior, and generally we see that it kind of does for a little while, but people kind of get bored with managing like something that seems so trivial as turning off a switch or other things like that. And so it's really those that were able to kind of invest in the technology that lets it happen kind of in the background without them having to actively manage and think about it. Those are the ones who stand to benefit the most. So one of the fears of this system of these data streams would be that insurance companies might be able to tell who has dialysis machines at home, or who's having midnight snacks, or opening the refrigerator at 3 o'clock in the morning. Being able to generate profiles of people that might be not doing the most healthy behaviors, and so could have their insurance premiums and things like that raised. That was why there has been a very big concerted effort to make sure that these data are basically HIPAA level compliant, so that they're essentially put on the same level as medical records and things like that. So if for instance, if you want to share, Google or Facebook or Amazon or any of these other big companies can't just get your data. If you want to get their services associated with your data stream, you have to sign that data over to them. You have to opt in, you can't opt out, which I think was a important part. That did make it harder for researchers like myself to work with like anonymized data and things like that. But I mean, there's always that trade-off you have in terms of, protecting privacy and things like that. So I think the real thing is people could have been hurt with privacy issues.
You explained how they work, but can you explain maybe how they are built, implemented, and then the data is recorded process?
A lot of the kind of smart grid 1.0, smart grid 2.0, 1.5, somewhere around in there, it's fuzzy. A lot of it was focused around the electricity meter. So that's the physical piece of infrastructure that the electricity or the electric utility, puts on the side of your house or is located somewhere in your building, that is measuring the amount of electricity that's going, into your house. And some of those data there's some local cache storage there, and then at daily or so, those data would be sent back to the electric utility and put into some sort of database associated with linking that electricity use linking those electricity use profiles to a particular service address or things like that. And so that is kind of like a rough ballpark of kind of how that was done. But the limitations of that was you're just looking at the whole home consumption, and so you don't know what's an air conditioner, what's a refrigerator, what's a heater, what's a microwave. And so there have been a lot of folks who have tried to do a bunch of disaggregation algorithms to figure out, can we take this this whole home stream of data and break it down into end use components using some machine learning techniques and things like that. And there's been some mild levels of success. As the whole home streams get more granular, it gets easier. So, if you're talking about hourly data, it's pretty hard to do really anything with hourly. 15 minutes better. You really need 5 or 1 minute data to be able to really kind of break that part out and move and do any like, kind of circuit level or sub-circuit level analysis with that. There are other companies and other programs and other pilots that are, that are looking to measure induced circuits directly. And a lot of times these disaggregation algorithms I talked about earlier are trained on these data, but there are these other companies that, they'll measure, they'll put little current transducers, which measures the flow of electricity over a wire that's going to your refrigerator or the wire that's going to your air conditioner. And so it's measuring those directly. And so you know exactly when those are turning on and turning off. And then those data are generally for those types of devices, those are more consumer level electronic devices. And so those, probably or should have some cache storage on the system itself, and then it's generally uploaded over the homeowner's or user's internet connection and sent to some database somewhere in the cloud.
And you mentioned some of the innovation that's happened from 1.0 to 1.5 or 2.0, where
Yeah.
we're calling it. What innovation still needs to happen, or maybe what policy needs to happen for this to be an effective solution?
Unfortunately, I think we've kind of stopped at kind of just measuring a whole bunch of the data, and we haven't really had a real concerted effort to make sense of kind of what's going on or to provide that feedback. Just telling people what their energy use profiles look like or giving them access to their data is great, but people, the average person generally can't make heads or tails of what, their 15-minute interval electricity use consumption data are or what they're telling them that is happening. And so, being able to, to better say, you're using more electricity than your neighbor, you may want to, in a or a home that's like yours, you may want to consider investing in efficiency upgrades or things like that. I think there's a lot of comparative analysis that could still be done on pretty base level electricity use consumption data that we're kind of missing out on. And it doesn't really even take the fancy stuff to do that. Even the 1.0 and the 1.5 could really do a lot of that. I think people are just finding it's a lot harder than they thought it would be.
What are some of the best resources to learn about smart grids, and especially in relation to climate change?
So a lot of the original funding for kind of the smart grid kind of 1.0 kind of came out of the American Recovery and Reinvestment Act. It was kind of one of the big tranches of funding that came out of the financial recession, 2008, 2009 era. And so a lot of the first rounds of funding came through that, including funding for my research, my dissertation work, full disclosure. And so there were a lot of reports that kind of came out of that one that kind of explained what it is, kind of how things were going. I wrote a few academic papers that I don't expect that many people to read, but in nature policy or in energy policy about how we were doing things in Texas, where I'm located, which has one of the largest penetrations of smart meters across the states. But it's generally a lot of it's kind of moved into that, the latest kind of machine learning, techniques and algorithms and supervised and unsupervised learning techniques that people are trying to use to, make heads or tails kind of this data.
Right now, you're speaking to passionate students who want to actually solve problems like these. What top 3 skills should they study so that they actually have the ability to do so?
Yeah, so it's really a lot of the machine learning techniques that are pretty popular kind of out there. So a lot of both supervised and unsupervised learning techniques, clustering analyses of these things. So some of the early work that I did was, clustering daily profiles for different types of homes and then using characteristics to try to predict like which home would be in, which cluster. And so it basically, all of that to say was, to try to help predict, which homes would be best served with receiving either energy efficiency upgrades or other types of things like that. Because, the way that our current programs work is we offer them to everybody, which in some level is a little more equitable, but there are certain, homes that would benefit more. There are certain customer classes that would benefit more from some of these programs than others. And so maybe one idea was, to not necessarily not offer them to everyone, but to target those that would be the most, beneficial or something like that. So, but to do all that, I mean, one has to, be able to one has to be able to manage to large data sets. So this class I teach at the University of Texas, I tried to call it Too Big to Excel, but they wouldn't let me necessarily call it that. It's got some other more boring name, but it generally, with joke being Excel can handle 1.8 million rows or something like this. We're talking about billions, if not trillions, by looking across the entire US. So high performance database techniques, being able to handle these extremely large data sets, but not only read and store them, but be able to, ingest and use them. So whether that's, all flavors of, machine learning techniques come in handy here, and, making sure you're, up to date with the, the most, sophisticated, mathematical modeling languages and things like that.
Any final recommendations for the audience?
I think this particular space is one of the richest data sets out there. And so I think it has the potential to make one of the biggest impacts if, people can, wrap their heads around it and get it. So, I mean, yeah, I'd encourage anyone who's interested in taking on a truly wicked problem to, to put their, to consider putting some effort there, because I think it could really make a difference.
Let's practice our skills we have been learning with energy. Imagine a scenario where a city plans to integrate more renewable energy sources. Create a plan outlining how a smart grid can facilitate the integration, manage intermittency, and optimize energy distribution.
Thank you for taking the How to Solve Climate Change course. If you want to learn the skills to solve this global challenge, join us for free at plato.university for exclusive content, extra resources, and actionable exercises with every lesson. This course was produced by Plato University, where students turn passions into purpose and learn skills to change the world. Learn more at plato.university.